Hi students, welcome to this section on basic remainder theorem. This is a very useful theorem that helps us in many questions where we are asked to find the remainder, and this method deals with factorizing the numerator. Alright, what do I mean with factorizing the numerator? Let's take an example. Say you want to find 21 into 7 by 4 and you want to find the remainder. Alright, you could have also thought of this as 147 divided by 4 and finding the remainder, right? Because 21 into 7 is 147. So by factorizing the numerator, I write 147 as 21 into 7. Now, if I have done this and I want to find this remainder, as per this theorem, this is equal to 21 by 4 finding the remainder and 7 by 4 and taking the remainder. Alright, so what would that be? 21 by 4, if you take the remainder, you can see that it's 21 is 5 into 4 plus 1, so you get a remainder of 1 over here, and 7 by 4 you get a remainder of 3, and 1 into 3 is 3, and that's your answer. So you can see that 21 into 7 by 4 remainder and 21 by 4 remainder into 7 by 4 remainder is the same, and in this case it's 3. Let's just for checking purpose do it over here. 21 into 7 is 147. If you divide this by 4, right, it goes 3 times. You get 12 over here. You have a remainder of 2 and you take your 7 down. That goes 6 times. That's 24 and you are left with a remainder of 3, and that's the same that we got over here. Alright, now say you want to find out 2 to the power 32 divided by 17 and you want to find the remainder. Let's see how we can use this same property that we have just now learned as per the basic remainder theorem. Let's see how this helps in solving this problem in a very easy manner. Alright, now you know that 2 to the power 4 is 16, and if you do 16 by 17, your remainder is minus 1, right? And remember, in the case where the divisor is 17, a remainder of minus 1 or a remainder of 16, both are one and the same, right? We have already seen that in many videos. Let me quickly repeat that. Why is that so? It's because you can write 16 as 0 times 17 and then you have to add 16. So your remainder over here is 16. Or you can write 16, which is the dividend, as 1 times 17 minus 1, right? So over here your remainder is minus 1. So a remainder of 16 and a remainder of minus 1 is one and the same. Alright, now let's come back to our question. We need to find out 2 to the power 32 divided by 17 and take the remainder of this. Alright, and we know 2 to the power 4 by 17 gives you a remainder of minus 1. Alright, can I say that 2 to the power 32 can be written as 2 to the power 4 the whole to the power 8? Yes, right? Because we know a to the power m to the power n is nothing but a to the power m into n. Using that, I can write 2 to the power 32 as 2 to the power 4 to the power 8. So this question and this one is one and the same. So 2 to the power 32 by 17 taking the remainder is the same as 2 to the power 4 to the power 8 by 17 and taking the remainder. Alright, let me keep that aside. Now, if I want to find this one, as per the basic remainder theorem, I have 2 to the power 4 occurring 8 times, right? So I can split it and factorize it and write it like this, right? I have 8 times 2 to the power 4 and I divide that by 17 just like we did it over here, right? Now we know 16 by 17 gives you a remainder minus 1. So this would be minus 1 into minus 1 into minus 1 8 times, which is equal to minus 1 to the power 8. That gives you the answer as 1. So we have seen that 2 to the power 32 divided by 17 gives you a remainder of 1. Just try on your own how would you approach 2 to the power 33 by 17, right? Try to find this on your own. I'll give you a clue. This would be the same as 2 to the power 32 by 17 remainder into 2 by 17 remainder, right? Because I can write 2 to the power 32 as 33 as 2 to the power 32 into 2. Let's do this problem. 73 into 75 into 78 into 90 into 91 into 92. You need to divide this by 34 and find the remainder. Pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. So the question is 73 into 75 into 78 into 90 into 91 into 92 divided by 34, and you need to find the remainder. Alright, as per the basic remainder theorem, I can rewrite this expression like this. Right? So I have taken each of these and divided them by 34, and I've written it separately. So I have over here 3, 4, 5, 6 terms, right? Now let's do each one. 73, if you divide it by 34, you will get a remainder of 5, right? Because 34 into 2 is 68, and you will see that 68 plus 5 is 73. Similarly, 75 by 34 will give you a remainder of 7. 78 by 34 will give you a remainder of 10, right? Again, 34 into 2 is 68. 68 plus 10 gives you 78. So your remainder over here will be 10. And if you do 90 by 34, your remainder will be 22, right? 68 plus 22 is 90, right? Similarly, over here it will be 23, and over here it will be 24. All right. So as per the basic remainder theorem, we have rewritten this expression like this, and this over here is equal to 5 into 7 into 10 into 22 into 23 into 24. Now, because this expression over here is greater than your divisor, which is 34, right? Therefore, after you multiply this, you have to divide this again by 34, and you need to take the remainder. All right. Now, again, we don't need to multiply all of these to find the remainder. Instead, we can again apply the basic remainder theorem, right? So let me just take 5 and 7 together, that's 35, right? And 35 divided by 34 will give me a remainder of 1, because 35 is 1 into 34 plus 1. Alright, so let me write that over here. Now let me take 10 and 22, that's 220. If I do 220 divided by 34, what would be the remainder? Let's by trial and error check out what is a close multiple of 34 that gets close to 220. So I can see that 34 into 7 gives me 238. Alright, make some space over here. 34 into 7 gives me 238. Over here I have 22 into 10, that's 220. So I can see that 220 is 34 into 7 minus 18, right? So I can say 220 is equal to 34 into 7 minus 18. Therefore, I can say that 220 by 34 gives me a remainder of minus 18, right? So let me write that over here. All right. Now, when you do 23 by 34, right, you can say your remainder is either 23, because 23 is equal to 0 times 34 plus 23, or you can see that 23 is equal to 1 times 34 minus 11. So I can say that a remainder of 23 is the same as a remainder of minus 11. Similarly, a remainder of 24 can be thought of as a remainder of minus 10. Now, if I do minus 11 into minus 10, I get 110, right? So 110, if you divide that by 34, you will get a remainder of 8. Alright, now why is that so? Let me make some space over here. You can see 34 into 3 gives you 102, right? And if you want to reach 110, so I can say 110 is 34 into 3 plus 8, because this is 102. Therefore, I can say that 110 divided by 34 gives me a remainder of 8. Now, because minus 18 into 8 is again greater than 34, I need to divide this again by 34 and find the remainder. So that would be this expression divided by 34, and you take the remainder. Minus 18 into 8 is minus 144 divided by 34, and that will give you the answer as minus 8. So 144 divided by 34 gives you a remainder of 8. So minus 144 divided by 34 will give you a remainder of minus 8. Let's see it together. I'll make some space over here. Let's see that why it's minus 8. 34 into 4 is 136. So you can see 136, if you add 8 to it, you will get 144, and that's why your answer is minus 8 over here. And remember, when your divisor is 34, a remainder of minus 8 is the same as a remainder of 26. And note 26 plus 8 without the minus. 26 plus 8 is equal to 34. Let's do this problem. Find the remainder when 10 to the power 5 is divided by 7. Alright, so the question is 10 to the power 5, you divide that by 7 and you need to find the remainder. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you've given it a try. As per the basic remainder theorem, I can write 10 to the power 5 as 10 into 10 into 10 into 10 into 10, right? So I can rewrite this expression over here in this manner, right? I've split it into 5 tens and I've written each term separately. So I have 5 terms over here. Now 10 divided by 7 gives me a remainder of 3, right? Because 10 is equal to 1 into 7 plus 3. So this becomes 3 into 3 into 3 into 3 into 3. Now because this expression is greater than 7, which is my divisor, I need to divide this again by 7 to get the remainder. Alright, now let me take 3 into 3 together. 3 into 3 is 9 and 9 by 7 gives me a remainder of 2, right? So I write that over here. Similarly, I have 3 into 3 over here. That gives me a remainder of 2 and I'm left with 1, 3. Let me write that 3 over here. Again, 2 into 2 into 3 is greater than 7. So I need to divide this by 7 to get the remainder. And I get 4 into 3, that's 12. 12 divided by 7 gives me a remainder of 5. And that is equal to a remainder of minus 2 because the divisor over here is 7. And you can note that 5 plus 2. Over here you do not take the negative sign. 5 plus 2 is equal to 7. Hi students, welcome to this section where we discuss about Fermat theorem. We'll also discuss what we mean with Euler number, how to find Euler number, and how to apply this concept in questions dealing with remainder. Alright, now the Fermat theorem says that if you have an expression like this where you can see x over here and n over here are co-prime, that means they have no common factor other than 1, right? Let me write that over here. For example, if you have 7 and 13, right? These two will have no common factor and the power to which x over here is raised has to be equal to the Euler number of the denominator. Now, the Euler number of 13 is 12. I'll tell you how to find that soon. But if you were given an expression like this, you can immediately say that the remainder of this expression is equal to 1 as per Fermat theorem. Alright, now let's try to understand this in greater depth. Let me keep the theorem over here and we move forward. Let's start with what we mean with Euler number. The Euler number is the number of co-primes less than the number and you have to take 1 also. That's why you add 1 to it. For example, let's find the Euler number of 8. We have 8 over here. As per the definition, the Euler number is the number of co-primes less than 8 and you have to add 1 to it, right? Let me write all the numbers before 8. That's 1, 2, 3, 4, 5, 6, 7, right? Out of these, which are the numbers that are co-prime with 8? You can see that 3, 5 and 7 are co-prime with 8, right? Because in the case of 2, 2 is a factor of 2 and 8, so 2 is not co-prime. In the case of 4, 2 and 4 are common factors, so 4 is not co-prime with 8 and 6 is also not co-prime with 8 because 2 is a common factor of 6 and 8, right? But 3, 5 and 7 are co-prime with 8 because the only common factor that these numbers have with 8 is 1, right? And you need to include 1 also, right? Therefore, the Euler number you can see of 8 is 4. These are the 4 numbers 1, 2, 3, 4. Therefore, the Euler number of 8 is 4. Let me repeat. The Euler number is the number of co-primes less than the number plus 1. And these are the 4 numbers that satisfy this condition. Therefore, the Euler number of 8 is 4. Alright, let me keep that aside. Now, say you have a question that says 13 divided by 8 and you raise 13 to the power 4 over here, right? So 13 to the power 4 divided by 8 and you need to find the remainder. As per the Fermat theorem, you can immediately say that the answer to this question is 1. Why is that? You can see 13 and 8 are co-prime. There is no common factor between 13 and 8, and we have just seen that the Euler number of 8 is 4, right? Therefore 13 is raised to the Euler number of 8, which is 4. Therefore, as per the Fermat theorem, 13 to the power 4 divided by 8 gives you a remainder of 1. Alright, now let me keep this aside and see how we can quickly find the Euler number of any given number. Let's do that. Alright, so we are trying to find the Euler number of any given number. We know one method of finding it. Like we can write it like this and check each and every number which is less than the given number to find the Euler number of that number. But this is tedious, right? This is a tedious process. So let's find an easier method to find the Euler number. So say you're given a number n and you prime factorize it and you get n is equal to a square into b cube into c. We have already seen what prime factorization is. So you have a, b and c, these are prime numbers, and n is written as a square into b cube into c. Now if you have achieved this over here, you can easily find the Euler number of n, the number over here. That would be equal to n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. Alright, let's try to learn about this formula a little bit more, and let's try to apply it in the case of 8. We already know that the Euler number of 8 is 4, and we have seen how in a manual method we were able to arrive at this, right? Now let's try to find the prime factorization of 8. So 8 is equal to 2 cube, right? Therefore, as per this formula, the Euler number of 8 is equal to 8. Here n is 8, right? And it has only one prime factor, so you'll just have n into 1 minus 1 by a, where a is 2. So that would be 8 into 1 minus 1 by 2, which is equal to 8 into 1 by 2, and that is equal to 4. And you can see that that's the same value that we got over here, right? It's the equal value. So this method works, and now we have found a method to find the Euler number of any given number. And also remember, in the practice problems we'll see two cases. We'll see a case like, for example, if you have 7 by 13 to some power, say in this case let me raise it to 12, you will see that the Euler number of 13 is 12, because 13 is a prime number, right? 13 is prime number. For a prime number, if you want to find the Euler number, you just have to subtract 1 from it. So 13 minus 12 will give you 13 minus 1 will give you 12. So 12 is the Euler number of 13, right? Now as per this formula also you'll get the same thing. You can just write 13 as 13. There is no other way. So in the case of 13, the Euler number is 13 into 1 minus 1 by 13, right? That gives you 13 into 12 by 13, and your answer is 12. So instead of doing this, you can just subtract 1 from the prime number and you will get the Euler number of that prime number. Alright, now what I was saying is, in the practice problems we'll have two types of problems. Say case 1 is, in the question given, this number over here and this number over here are co-prime. So in that case we just apply Fermat theorem. The second case you will see, for example, if you have an expression like 7 by 14 to some power, say 12 for example. In this case you can see that 7 and 14 are not co-prime. So we'll see in the practice problems how you can attack this type of a problem. Basically you need to make it co-prime by taking out the common factor. We'll see that in the problems. Let's do this problem. 11 to the power 97 is divided by 18 and you have to find the remainder. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. To start with, you can note that over here you have 11 and over here you have 18. It's easy to observe that 11 and 18 are co-prime. That means 11 and 18 have no common factor other than 1. Alright, so it's in a good format to apply Fermat theorem. Now the power over here is 97 and the denominator over here is 18. We know that 11 divided by 18, and if you take the Euler number of 18, right, as the power of 11, the remainder would be 1 as per Fermat theorem. Alright, Now let's see what the Euler number of 18 is. For that we start by prime factorizing 18. Alright, so I can write 18 as 2 into 3 square, right? As per the prime factorization of 18, I have two prime factors, 2 and 3 is to the power 2 over here. Now therefore the Euler number of 18 is equal to 18 into 1 minus 1 by 2 into 1 minus 1 by 3, right? That's 2 over here, that's 3 over here. These are the two prime factors of 18. So I just have two expressions over here. So 18 into 1 minus 1 by 2 into 1 minus 1 by 3. That gives me 18 into 1 by 2 into 2 by 3, and that simplifies to 6. So the Euler number of 18 is equal to 6. Now I need to express 97 in powers of 6 and see what remainder I get. Let's try to do that. Alright, if I do 97 divided by 6, right? Let me do it in a long manner over here, but you can do it mentally. 97 divided by 6, you can see that you get your quotient as 16 and your remainder is 1. You can do that mentally also. How do you do that? You just need to find this remainder over here, right? Because the quotient does not actually matter. We just need to know what the remainder is. For example, over here from this we find that 97 is of the form 6k plus 1. So k is representative of the quotient. That does not matter for us, because whatever the value of k is, we'll get the remainder as 1, right? Say for example, if you have 11 to the power 6k divided by 18, whatever the value of k, your remainder is 1 as per Fermat theorem, right? Because the Euler number of 18 is 6 and 11 to the power 6k can be written as 11 to the power 6 to the power k. So 11, say for example, for your understanding, let me take k as 2. So 11 to the power 6 into 3 divided by 18. If you're finding the remainder, I can write this as 11 to the power 6 by 18. Take the remainder into 11 to the power 6 by 18. Take the remainder into 11 to the power 6 by 18 and take the remainder. This is as per basic remainder theorem, right? Therefore, you can see that the quotient over here 3 does not matter. It's just 1 into 1 into 1 in this case. If it was 4, it would be 1 into 1 into 1 into 1, right? Therefore, we are interested only in this remainder. Let me make some space over here. Now, we were discussing how you can do this mentally. You basically need to do 97 divided by 6, right? Let me just show it to you how you can do it mentally and make some space over here. So we are trying to do 97 by 6. We can see that 9 by 6 it goes once, right? So you have 1 and your remainder is 3. Keep that in your mind. Take 7 along with that, so you have 37, and you know 37 by 6 goes 6 times, that's 16, right? And you get your remainder 1. So you just need to remember your remainder 1, and we get to establish that 97 is of the form 6k plus 1. Alright, now after you have achieved this over here, let's keep this aside. So I know that 97, the power over here is of the form 6k plus 1. Therefore, the question over here, that is 11 to the power 97, you divide that with 18 and you want to find the remainder. This question can be written as 11 to the power 6k plus 1 divided by 18 and you take the remainder. And k over here is 16. We have seen that, but it does not matter. So this can be rewritten as 11 to the power 6k by 18 remainder into 11 by 18 remainder, right? Because 6k plus 1 is written like this, 6k, and this is like 1. Alright. Now, as per Fermat theorem, we know that 11 to the power 6k, when you divide that with 18, you get a remainder of 1, and 11 by 18 will give you a remainder of 11. So your answer is nothing but 1 into 11 or 11. Remember, the things that you have to check over here is 11 and 18 are co-prime, right? And you have found that the Euler number of 18 is equal to 6. These two things are what you need to check. That's why this expression over here gets simplified to 1, and you have 1 into 11 and your answer is 11. Therefore, 11 to the power 97 divided by 18 remainder is equal to 11. Let's do this problem. 2 to the power 102 divided by 100, and then you need to find the remainder. Pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. Over here, you can see that the numerator and denominator are not co-prime, right? You can see you have 2 over here and 100 over here, right? You have 2 over here, you have 100 over here. These two are not co-prime. Therefore, to proceed, you need to make them co-prime. Now, over here you can see that in the denominator you have 100, and 100 has 2 powers of 2, right? 100 can be written as 2 into 2 into 5 into 5 when you prime factorize it. Now, only if you remove this part over here from the denominator will the numerator and the denominator be co-prime, right? So therefore, you have to remove the common factor of 4. Let me write that over here. So you need to remove the common factor of 4. So let's take out 4 both from the numerator and from the denominator. When we do that, we are left with this, right? So I have over here 2 to the power 102. I'm taking out 2 2's, right? So this becomes 102 minus 2, that's 2 to the power 100. Similarly, from 100 I am taking out 2 to the power 2. So we have seen 100 is equal to 2 into 2 into 5 into 5. So I am taking out this part over here and I'm left with 5 into 5 or 25. Now, it's very important that you don't miss out this part. The step is step 1, you solve this part over here, and then whatever you get over here, you need to multiply it with 4 to get the answer. Now let me quickly explain to you why that is. We know 2 by 4 is equal to 1 by 2 because both of them are equal to 0.5. But if you find 2 by 4 remainder, your answer is 2, right? Because 2, the numerator over here, can be written as 0 times 4 plus 2. But over here, you can see if you find 1 by 2 remainder, your answer is 1. Why is that? Because this one over here can be written as 0 times 2 plus 1, right? So if you find 2 by 4 remainder, and if you take out 2 both from the numerator and denominator, this becomes equal to 2 times 1 by 2 remainder. In that case, you get 2 into 1, which is 2, and you can see that the answer over here and over here matches. It's the same, right? So the same concept applies over here. We have taken out 4 as a common factor out from the numerator and the denominator. Therefore, after you find the answer to this part, you need to multiply it with 4 to get the correct answer. Alright, let me make some space and we'll move forward. Try to do this on your own while I make some space over here. Alright, over here you can see that the denominator you have is 25, right? What's the prime factorization of 25? 25 is equal to 5 square. Alright, therefore let's find the Euler number of 25. The Euler number of 25 would be 25 into 1 minus 1 by 5. That's 25 into 4 by 5, or you get your Euler number as 20. Alright, that means if I have 2 to the power 20 divided by 25, the remainder is equal to 1 as per Fermat theorem. Alright, now I can rewrite this expression over here as 4 into 2 to the power 20 to the power 5, right? Because I can write 2 to the power 100 can be written as 2 to the power 20 to the power 5, because a to the power m to the power n is equal to a to the power mn, right? Using this principle, I'm rewriting the expression like this. As per Fermat theorem, we know this part is equal to 1. So this part over here will simplify to 1 into 1 into 1 into 1 into 1, right? Because you have a power of 5 over here, and that's equal to 1 itself. Therefore, this expression simplifies to 4 into 1, and you get your answer as, remember not to forget to multiply 1 with 4, because many students might write it as 1 and leave it there, but that's not the correct answer. The correct answer over here is 4 into 1, which is 4. Let's do this problem. The question reads x to the power 6k, right? That's a k over here. When divided by 9 leaves a remainder of 1. x is a natural number less than 100, how many values can x take? And k is any natural number. Alright, pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. There's something that you can note over here. 9 is equal to 3 square, right? The prime factorization of 9 is 3 square. So the Euler number of 9 will be 9 into 1 minus 1 by 3, right? So that is 9 into 2 by 3, which is equal to 6. And in the question over here you have 6, right? Therefore, all you need to do is you need to find values of x such that x and 9 should be co-prime as per Fermat theorem. Now, before we move ahead, pause the video again. Try to solve it now. Alright, so we are back. We have seen that over here in the question itself, you have x to the power 6k. So if x is co-prime to 9, this expression always will give you a remainder of 1. So you just need to find out all the values of x less than 100 such that x and 9 are co-prime. Alright, now because we know that, let's try to find this out. What are the numbers that are co-prime with 9 that are less than 100? All non-multiples of 3 will be co-prime with 9, right? Because 9 is equal to 3 square. So the factors, any number which has 3 as a factor will have a common factor with 9. Therefore, all non-multiples of 3 will be co-prime with 9, right? So let's try to find out all the multiples of 3 which are less than 100. And if we add 1, 2, 3, if we count 1, 2, 3 up to 99, that's 99 numbers. So we just need to find out the multiples of 3 and subtract it from 99. Alright, what are the multiples of 3? 3 into 1 is 3, 3 into 2 is 6. It goes on till 99 because 99 is 33 into 3, right? We have 3 into 1, 3 into 2 up to 3 into 33. So this counts up to 33 numbers, right? We have 1, 2, 3, 4, 5, etc. up to 33. So all we need to do is we need to subtract 33 from 99. So 99 minus 33 gives 66 and that is your answer. So x can take 66 values such that they are less than 100 and these are natural numbers. And then for all of those 66 values, this expression will give a remainder of 1.